This presentation focuses on the IEC 63110 messages exchanged during the execution of the scenario of the Zamiran model. The IEC 63110 standard tries to give mobility actors the advantages of standardizing the data exchanged. The different components of the data exchanged are modeled according to an information model. This information model is represented in UML. To the left of the slide is displayed the hierarchy of packages, the domain package containing the data type data. The figure on the right shows a particular view of the model containing the main components. CSMS, that is Charging Station Management System. System responsible for managing charging infrastructures. EVSE, that is Electric Vehicle Supply Equipment. Equipment or a combination of equipment, providing dedicated functions to supply electric energy from a fixed electrical installation or supply network to an EV for the purpose of charging and discharging. Connector, an independently operated and managed electrical outlet on a charge point. EV, that is electrical vehicle. Here is an example of the diagram of a particular package, the device model package that groups physical devices. This involves defining the messages that are exchanged during the various operations between the charging station and the CSMS. For this, we use the profiling methodology, which has been defined in connection with the use of the CIM Common Information Model from the standards IEC 61970, 62325 and 62966-8. Here the reference information model is not the CIM but that of the standard IEC 73110. From the information model, a contextual model is derived describing the context of the exchange and describing all the data specific to this exchange. The name of this conceptual model reflects the name given to the message exchanged. This methodology is based on a concept defined by the UNC fact. Each element of the profile model is based on, i.e., based on, an element of the information model. More explanation can be found in the standard document IEC 62325 Part 450. Then we generate a syntax model, in our case XSD, using serialization rules of a UML model to XSD file. These rules are described in the standard IEC 62361-100. The messages exchanged between the CSMS and the charging station are defined within the framework of the displayed diagram, which is one of the architectures defined by the IEC 73110. In this case, the local CSMS is confused with the charging station controller. Messages exchanged between the CSMS and charging station use the XMPP protocol as support for message instances defined by the methodology described above. To model the context of the exchange of use cases illustrated by the model, it was necessary to extend the information model of the IEC 70110 with some classes marked by the stereotype, mockup. The new attributes or associations are also marked by the same stereotype. Two profiles, conceptual models, have been defined for the use cases illustrated by the model. A first model EV connection to define the messages of connection of a vehicle to EVSE, and another profile EV charge status to define the states of charge or discharge of a vehicle. The diagram shows the conceptual domain for EV connection. All profile elements are based on an element of the information model. As here, for example, the EVSE class of the profile is based on the EVSE class of the information model. An extract of the XSD message exported from the EV connection conceptual model is presented. From the XSD from EV connection are produced the payloads of disconnection connection messages, which are XML instances compliant with XSD. The example displayed shows the payload of the connection message of the vehicle driven by Andre to the EVSE named EVSE1 at 8 hours 30 minutes and 47 seconds. According to the identifier reservation 5, the message of type CSMS message is then created according to the principles of the IEC 61968-100 standard and sent according to the XMPP protocol to the mail server of the model, implemented with the Prosody product.